In this lesson, we're going to try to put all of the things that we've learned about quadratics together to solve problems. So let's try to remember what we have learned about quadratics. One thing that we've learned is this guy here. We know this is the quadratic formula. We can use it to solve quadratic equations. We've also learned how to factor. And we've learned 3 factoring techniques. We know how to common factor. We know decomposition and its shortcut, sum and product. And we also know how to use difference of squares. And we can also use that to solve quadratic equations. We also know how to find the vertex. We learned all about the shape of a parabola, how it either opens up or opens down. And we know parabolas are so easy to work with because they're symmetrical. So if we want to find the lowest point, which is the vertex, or the highest point if it opens down, we know that we can find it by finding the middle of the 2 x-intercepts, or 2 points that are opposite of each other. Whatever that middle is going to be is the x value of the vertex. And the last thing that we've learned is how to sketch the parabolas. So we know we can sketch with x and y intercepts, or we could use transformations. Let's keep all of those tools in mind when we're solving this problem. Before we even read it, take a look at this equation. Do you recognize what shape this would be? We're not used to working with t and h, but we are used to working with x and y. And we can see that t is where the x usually is, and h is where the y usually is. We can also see what degree this equation is. The highest exponent on t, which is our x, what we typically have as our x variable, the highest exponent is 2, and the highest exponent on the y variable is 1. So this is going to be a parabola. Let's read this question now. It says a soccer ball is kicked into the air. Its height in meters is approximated by this equation, where t is the time in seconds since the ball was kicked. Does this make sense that this shape is going to be a parabola? So imagine instead of x and y, we have t down here and h over here. And it says that t is our time in seconds and h is our height in meters. So this looks like it's a parabola. It's going to open down. So let's make a sketch of what this thing could look like. So it looks like it's a parabola that opens down. Does this make sense that a soccer ball would be kicked in this shape? It does, because if a soccer ball is kicked, it's going to go up in the air and it's going to come back down. So once we have a sketch, let's try to answer these questions. It says, from what height is the ball kicked? So where in this parabola is the ball kicked from? It's kicked right from here. So let's put a big dot here. This is the point where we're looking for. That's the point that it kicked from. And the question is, what is this height? We don't know the height. If we're looking for one variable, in this case we're looking for our y variable, or we're calling it height right now, that means we must know the x variable, or in this case it's time. What is the time at this point right here? Since it's along the y-intercept, we know that the time is 0. So that means that we're looking for the height when the time is 0. So time is equal to 0, and we need the height. We don't know what the height is equal to. So let's plug it into our equation. So here's our equation, and let's plug in t is equal to 0. So we got h is equal to -2. We have 0 squared plus 8 times 0 plus 0.5. And we know all those terms are going to be 0 except for the 0.5. So we just plugged in x essentially is equal to 0. So we know what that is. That's a y-intercept. We just found this y-intercept. When the time is 0, the height is 0.5. So let's add it into our graph. We know that this height is 0.5. 0.5 what? It's in meters, because it says here that the height is in meters. So this is going to be the starting height, or the height that the ball is kicked from. So notice for this question, it didn't explicitly say that the time is 0. This is what makes this an application question. We need to do a sketch first for what this problem is, and then figure out from the sketch what it's asking for. Let's do the same for part B. Part B says, after how many seconds will the ball hit the ground? The question is, when does the ball hit the ground? We know it starts at 0.5, so it's not on the ground. It's going up, 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 all the way to there. We're looking for this point right here. So what do we know about it? We have to know something about it. It says, after how many seconds will the ball hit the ground? So that means we're not looking for the height, we're looking for the time. So we need this value right over here. What is this x value? We know this x value is 0. What's this x value? If we don't know the x value, we must know the y value. Do we know the height of the ball when it's on the ground? Of course we do. It's 0. So in this question, we're looking for the time, how many seconds, and we know that the height is equal to 0. So if we know the height is 0 and we don't know the time, all we need to do is plug in h is equal to 0 into our equation. So let's write this equation out again, but we're going to plug in 0 for h. Now that we have plugged in h is equal to 0, what tool can help us solve this? We have multiple t's here of different degrees, so we can't isolate for t. So we have to use either factoring or quadratic formula here. If we want to use factoring, we'd have to use decomposition. But looking at this decimal, this is going to make it a little bit difficult. So we should use the quadratic formula here. So here's our A, here's our B, here's our C. So go ahead and write out the quadratic formula and start filling in your letters. If you've started this video again, you should have filled out the quadratic formula on your own. Before I show you my answer, have you divided the entire numerator by 2a? And also have you made sure that we have negative b? So here's what it should look like, all filled in. Here's what it should look like. Next step is we're going to calculate the discriminant, so throw that into the calculator. Make sure you've calculated the discriminant on your own before checking my answer. So pause the video if you haven't. You should have 68 here. And our last step is finding our two answers. So one answer will be negative 8 plus root 68 divided by negative 4, and the other will be negative 8 minus root 68 divided by negative 4. Here are the two answers that you should get. Don't just copy from this video. Make sure that you've tried it on your own. If you got a different answer than me, ask yourself, did you do this whole entire numerator first, press equals in the calculator, and then divide it by negative 4? So it should have negative 8 plus root 68, press equals in the calculator, and then divide that answer by negative 4. And then do the same thing for the minus. These are the two answers that we're going to get. So let's go back to what this question said. This question said, after how many seconds will the ball hit the ground? So we're looking for this answer here. Why did we get 2? Well, which answer would this one be? Would this make sense that it could be negative 0.06 seconds? That doesn't make sense. It's on the positive x-axis. This must be 4:06. So this must be the time 4.06 seconds. So then what is this one? Is this useful in our problem? First of all, did the calculator give us a mistake? This quadratic formula will never give us a mistake. It will always give us one of the solutions. It just might not be a useful solution. What we just solved for when we plugged in h is 0 or y is equal to 0, we just solved for an x-intercept. How many x-intercept is this parabola going to have? Well, we have one here. But isn't the parabola going to hit this x-axis over here as well? So we have this part of the parabola over here in blue. That's not useful in this problem. And it's not useful because time can't go backwards. This story started when the ball was kicked, and the ball was kicked at time 0. Whatever this amount is, actually, we know what it is. It's negative 0.06 seconds. That's not helpful in this problem. So what we do is we call this number here, we call it extraneous. It's not that it's wrong, it's just it's not helpful in this problem. And so the answer that is helpful is this guy right over here. This is the x-intercept we're interested in. So to answer the problem, the ball will hit the ground after 4.06 seconds. Notice none of these problems tell us explicitly what to do. We need to use the clues from our picture and what's given in the question to figure out what we're given and what to do. Let's try another one. Part C says, what's the maximum height of the ball? So what point are we looking for here? It's this guy right over here. We know that this is the maximum point of the ball, and we also know that the maximum point is the vertex. So what is this height? We know it's higher than 0.5, but we don't know exactly what this height is. Do we know anything about this point? Remember, if we're looking for y, that means we must know x. What do we know about this x coordinate? What do we know about this x coordinate? Have you thought about that the vertex is in the middle of the parabola? And so if we have these two x-intercepts, we can find the middle. So should I check what's in the middle of 0 and 4.06? Or should I use this point here? Do you remember what this point is? We found it in this question. It's negative 0.06. So if we want to find the vertex, we have to find the middle of not 0 and 4.06, but our two x-intercepts. So let's add those x-intercepts together and divide by 2, and then we'll have the x value. Can you calculate this on your own? Add our two x-intercepts together, divide by 2. What do you get? You should get exactly 2. That is the point that's exactly in the middle of these two x-intercepts. So this question is asking for the maximum height. Just like every other problem, we got to sketch it out. And if we're looking for height, that must mean that we have the time. We just had to figure it out there. We know it's going to hit its maximum at 2 seconds because it's in the middle of our two x-intercepts. So then how are we going to find that height? Well, we're going to do what we did in all the other problems. We're going to plug it into our equation. So I'm going to take this equation and let's plug in x is equal to 2. Once you plugged in x is equal to 2, put it into your calculator and you should get 8.5. So what did we just find? Let's put it back into our picture. We plugged in x is equal to 2 and we got a height of 8.5. So let's add that onto our sketch. So this guy up here we know is going to be 8.5. And the question is asking, what is the maximum height of the ball? Well, we know it's going to be 8.5. We know height is measured in meters. So the maximum height of the ball will be 8.5 meters. Let's work on one last problem. It says the ball is kicked beside a swing set that's 4 meters tall. For how long will the ball be able to be seen above the swing set? I'm just going to repeat our sketch right down here so that we can see it on our same screen. So I'm just going to copy our sketch from above and put it down here. Now that we have our sketch, let's try to figure out where this 4 meters goes. So it says the ball's kicked beside a swing set. So maybe the swing set's right in front of it and the ball's kicked right beside it. And it says the swing set is 4 meters tall. So if this is the maximum height of the ball, 4 meters is maybe somewhere there. For how long will the ball be able to be seen above the swing set? So we're looking for when is the ball going to be above this 4 meter mark. So if I were to take this across, if that's about where 4 meters is, the ball will not be able to be seen above the swing set from here. But after this point, it's going to be above 4 meters, above 4 meters, above 4 meters, above 4 meters, until this point. And then after that, it's going to be below the swing set. So the question is saying, how long will it be above here? How long will it be above here? To figure out how long, we need to know these times. We need to know the time when it starts at start being above 4 meters, and it ends being above 4 meters. So we need to find these times. So we're always looking for either height or time. Or in this, like in any case, we're always looking for either x or y. And in this case, we're looking for x, which means we must have y. And we do. It's 4. So we have the height and we're looking for the time. So we know what to do. We're going to take our equation, but this time we're going to plug in height is equal to 4. What tool can help us solve this? We've got two t's again. They have different degrees, so we're never going to isolate them. So we got to use the quadratic formula or factoring. But neither can be used if one side's not equal to 0. So we got to get rid of this 4 first. So I'm going to subtract by 4 on both sides. And on this side, we'll have 0 equals negative 2t squared plus 8t. And then we've got 0.5 minus 4, which is going to be negative 3.5. So we have a choice between factoring and quadratic formula. If the factoring was easy, I'd say let's do factoring. But we got this pesky negative 3.5. I don't want to think of numbers that multiply to this guy here. Although two numbers that multiply to negative 2 times negative 3.5, that's negative 7. That might work, but let's just use quadratic formula anyways. So we know our A value is negative 2, our B value is 8, our C value is negative 3.5. Throw it all into the quadratic formula. So pause the video and put it all together. Next step is to calculate the discriminant. So check in your calculator exactly what the discriminant equals, pause the video, and start it again once you have it. The discriminant we got should be 36. And we know we can take the square root of 36. It's going to be 6. So that means that this was factorable. So if we had multiplied negative 2 times negative 3.5, we'd be looking for two numbers that multiply to 7 and add to 8. And those numbers would have been 7 and 1. We could have factored this. But let's keep going. Now that we've used the quadratic formula, can you find x1 and x2? Pause the video and try it yourself. So the two values we should get are 0.5 and 3.5. So that comes from negative 8 plus root 36 divided by negative 4, and then negative 8 minus root 36 divided by negative 4. Do these numbers make sense? Let's put them in here. Does it make sense that both of these answers are positive? They should be positive. Both the answers should be positive here. So it makes sense that this one must be 0.5 and this one must be 3.5. So let's add them in. So this one must be 0.5 and this one must be 3.5. So the question is, how long will the ball be able to be seen above this swing set? So the ball's exactly at 4 meters at 0.5 seconds. And then it goes below 4 meters at 3.5 seconds. So for how long is this? Well, if it starts at 0.5, ends at 3.5, what do we got to do with these two? We just have to subtract them to figure out how long is that. How many seconds is it between 0.5 and 3.5? It's 3 seconds. So all we need to do is find the difference in x. So I'm going to put delta x. We know that that just means the change in x. We're just going to subtract them. 3.5 minus 0.5. And the change in x is just going to be 3. Instead of x, I just realized we're using t. I'm going to just cross it out and put t. Change in t is going to be 3 seconds. So we know that the ball will be above 4 meters for 3 seconds. So let's summarize what we did for this whole entire problem. None of these questions explicitly told us what tool to use, quadratic formula or factoring. It also didn't tell us what to plug in. We had to figure that out. And the only way we could figure it out is if we had a picture. So for all of our future word problems when it comes with quadratics, especially if we're given an equation, draw a sketch. Also, if you get multiple answers, sometimes one answer doesn't make sense. Sometimes both answers don't make sense, and we call them both extraneous. In this case, just one answer didn't make sense to us, so we called that one extraneous, and we used the one that worked.